So we are going to test for symmetry. This will be a quite quick exercise. Sorry, y equals 2x cubed. Okay, so the way to test it for symmetry here is what we're going to do is actually see if plugging in a negative y would change it. So if you have y equals 2x cubed and you plugged in negative y equals 2x cubed, would this be the same thing? Now the answer is actually no, not at all. Why? Because if you replace this negative on the outside, it doesn't, this still is positive over here. So this over here says positive equals positive, this says negative equals positive. So this would not work. Now what about changing the x to be negative? Negative x on the inside, and if you work out the math, you get y equals negative 2x cubed. Again, this wouldn't work because the negative, we're saying a positive equals a negative and a positive equals a positive. So that's not true. Finally, if we have y equals 2x cubed and we plug in negative for y and negative for x, what we're going to end up with is this. Now, can we divide both sides by negative? Yes. So we'll end up getting y equals 2x cubed. Is this the same statement as this up here? Yes. Okay? So plugging in both negatives produced the same statement. You notice that? But these two produced different. Okay? So they didn't work. So then the only one that works is the origin. So actually, this is kind of a rule with this right here. See that number? That's actually going to be kind of an odd power is going to cause symmetry with respect to the origin. Okay? Not all the time, but more times. Okay, now in the notes we see two examples. Y equals negative y squared, x minus y squared equals 1, which just equals x. And then we also have okay, now I just want to point out, this is a quadratic, okay? Now it's a quadratic that is horizontally oriented, which if you were to look at it would mean that you're going to move one over here and the graph is going to kind of look one, two, 3, 4. So you do it over here, and then flipping it, you're going to get something like this. So once you have symmetry, it's going to be easy to plot it. Okay. The same thing with this. We know that this moves it to the right. 1, and so then we're going to have a kind of step ladder this way. So if we use symmetry, we're going to have the same step ladder this way, okay? And so then this line goes here, and this line goes here, okay? So that's how we're using symmetry, okay? I use symmetry on both of these to graph the opposite side, okay? Now, we can talk about this if you have any questions, okay? The standard form of a circle. Let me go through this one quick. Standard form for a circle is x minus h, in parentheses, squared, plus y minus k, parentheses, squared, equals r squared, okay? So x minus h squared plus y minus k squared equals r squared. So that is the standard form of a circle. Now we're going to go over this far later, chapter 10, and a few times. But basically, you have a point that lies on the circle, which you're going to plug in for x and y, here and here. And you're going to plug this, negative 1, 2, in for k and h, and you're going to solve for r squared. Okay, now that's basically how you do that to solve for this one right here. Okay, we're going to move on and hopefully finish this. So we're going to 1.3, which is just linear. And so I'm actually going to skip to the end of 1.3, which is page 32. So if I go through this, and if you have issues with viewing stuff, I'm skipping over, I apologize. Okay, 32. You'll see summary of equations of lines. So it's going to give you a bunch of different forms, and I'm basically going to put it, okay? So the general form is actually what we use for, you use it as it's kind of the standard form for lines, okay? So this is, I'll call it, it's not really standard form, it's written a little bit different. So we'll call it general form. Is it important? You can know it. Okay, so it's ax plus by plus c equals 0, okay? The next form is a vertical line, okay? And a vertical line will be x equals a, and then a horizontal line will be y equals b, okay? Now, we'll keep on going. So slope-intercept. If you don't remember this, this is a great question to ask for class. Slope-intercept is y equals mx plus b, okay? And then point slope, which is also in these, is y minus, they do y sub 1 equals m times x minus x sub 1, okay? And that's point slope. Now do you need to type your notes? No, guys, you don't need to. Okay, 2-point form. Do we use this? No. So, it is in the book. We don't use this. You can know it. We don't use it. Okay? I don't choose it. Better guess. Okay. Now, quickly going over lines. There's a few things that we need to use. Okay, finding slope. That's an important equation. Sorry. Alt NEI. And we get m equals. So we have two possible formulas. We have y2 minus y sub 1 divided by x sub 2 minus x sub 1, or that is also equal to the same thing, but just switching the order. So y sub 1 minus y sub 2 divided by x sub 1 minus x sub 2. Okay, now I want you to notice something. The order has to stay the same. So this is 2 minus 1, or 1 minus 2. You cannot vary it on top and bottom. The other thing with slope is a crucial thing. X sub 1 may not, may not equal x sub 2, okay? They can't equal. If they equal, you have a hole in the fabric of reality. Just kidding. It's called derivatives. Okay, I'm sorry with this chord. Life happened. So two lines are parallel if they have the same slope. Okay? If they have the same slope. So you can just put it this way, m sub 1 equals m sub 2. Okay? Perpendicular means that they have the negative reciprocal. Okay? Think of it this way. M sub 1 equals negative 1 divided by m sub 2. Okay. Examples 1 through 4 are basically practicing point slope. I'm not going to go over them. That's if you do have trouble with that, that's a great time for you to spend, but not. And then we don't actually have scatter plots, so watch this. It's beautiful things going to happen. Actually, I can delete it later anyway. So it all vanishes. Okay. Oh, whoops. Sorry, applications. The application is from 5 to 8. I'll show you real quick, and then I'll post these videos. Okay? The application is essentially, let's look at 5. 5, finding the slope. They give us feet and they give us inches. So first thing we need to turn is keep the units the same. So the feet, i.e. 24 feet, we need to turn into 288 inches. So slope is vertical change over horizontal. The vertical is 22, which is rises. Horizontal is 24. So 22 over 288 is 0.76. Okay? Now, they said it needs to be a slope of 112. It's 112 at a maximum of 112. So 112 is this, 0.08. This is less than that, so we're fine. Okay? This is a fine slope. Okay? Using slope as a rate of change. Okay, essentially, you just plug it in. Okay, guys? This is our slope, and then you're going to find a point on that. Okay? Straight line depreciation, finding slope, and then making the equation. Okay? And finally, predicting sales is the same thing. You're just plugging in a number. Okay? That's those. We aren't actually going to do any practice problems on those, so don't worry. Examples 5 through 8 aren't going to be important. Okay? We'll see you guys soon.